Okay, today we were going to discuss the definition of the derivative of a function. So the derivative of f of x with respect to x is the function f prime of x and is defined as f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches infinity. So that is now similar to what our last topic. So let's apply that definition. So this is the definition of the derivative. So we have, so problem number one, find the derivative of the following function using the definition of the derivative. So the given function is f of x equals 2x squared minus 16x plus 35. So first I'm going to write the formula or the definition of the derivative. So we have f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0. Now, by substitution class, from the given of f of x equals 2x squared minus 16x plus 35, it means to say, so on the first term, we have f of x plus delta x, meaning to say that your x in the given function of f of x will be replaced by x plus delta x. So writing that one, so we have the limit of 2 times, so replace x now by x plus delta x to the power of 2 minus 16x minus 16x, replace x by x plus delta x plus delta x plus 35 minus the second term in the numerator is f of x, that is actually the given. So therefore, we replace f of x by 2x squared minus 16x plus 35. So we can write here minus, do not forget to write here the open quantity. So you have open parentheses of 2x squared minus 16x plus 35 all over delta x as delta x approaches 0. Now simplifying the numerator, so we can write now 2 times, we have 2 times the square binomial of x plus delta x will give us the answer of x squared plus twice the product of the two terms, that is now 2x delta x plus the square of the last term, we have delta x squared. Close parenthesis minus, using distributive property, we have now negative 16x, and negative 16 times delta x, we have negative 16 delta x plus 35. Then using distributive property, negative times the quantity of 2x squared minus 16x plus 35, so will give us the product of negative 2x squared plus 16x negative 35. Then this will be all over delta x as delta x approaches 0. So we need to simplify again on the first term. So we have to use distributive property. So we have the limit of 2x squared plus 2 times 2x delta x is 4x delta x plus 2 times delta x squared is equal to 2 delta x squared. And the remaining terms we can simplify as well. So we have here negative 16x will be cancelled with negative with positive 16x, as well as the positive 35 and the negative 35 because they are additive inverse. So I will write now the remaining terms of after delta x squared. So we have minus 16 delta x and minus 2x squared. So all over delta x as delta x approaches 0. But still there are like terms like 2x squared and negative 2x squared, and I guess there's no more like terms. So we can write now the the answer in the numerator, we have the limit of 4x delta x plus 2 delta x squared minus 16 delta x all over delta x as delta x approaches 0. So as you can see, we can now divide the numerator by delta x. Okay, so dividing by delta x, so we can write now the answer here. So we have, this is the continuation, so we have f prime of x is equal to the limit of, so dividing this one now, 4x delta x divided by delta x, so, or it's either you're going to divide right away, or you can factor out the numerator, which has a common factor of delta x. So for this example, I will just divide right away by delta x. So therefore, 4x delta x divided by delta x, so is equal to 4x plus the second term is 2 delta x squared divided by delta x. So the quotient is just equal to 2 delta x minus the last term is 16 delta x divided by delta x is equal to negative 16 as delta x approaches 0. Now, since it is now already the simplified form, now we are going to replace delta x by 0. So therefore, we have now, so we can write now here as 4x. We have 4x, so 2 times 0, that is now equal to 0 minus 16. So we have now 4x minus 16 is the answer of this problem. So the derivative of the given function, which is f of x equals 2x squared minus 16x plus 35 is equal to 4x minus 16. Okay, so next example, we have g of t is equal to t over t plus 1. So we are still asked here to solve using the definition of the derivative. So for this problem, so g of t is equal to t over t plus 1. So we will write first our formula. G prime of t is equal to the limit of um, g of t plus delta t minus g of t all over delta t as delta t approaches 0. So by substituting now to our, we are going to replace t by t delta t. So we have the limit of t plus delta t, that is now t will be replaced by t plus delta t all over t plus 1. So again, t is can be written as t plus delta t plus 1 minus the meaning of g of t, which is now actually the given. So we can write now t over t plus 1 all over delta t. So we can write it here properly, the equal sign, so it should be here. So the limit of this function here on the right side as delta t approaches 0. Now simplifying this one, so let us write first the limit of delta t as approaches 0. So in the numerator, we have to find the LCD. So actually the LCD is the product of the two denominators. So we can write here now as, we have to write the product form of the two denominators. We have t plus delta t plus 1 times t plus 1. Okay, that is our LCD. So the LCD divided by the first denominator. So the quotient is t plus 1 times the numerator. So I will write here now t plus 1, which is the quotient, times the numerator of t plus delta t minus the LCD divided by the second denominator, which is t plus 1. So we can cancel t plus 1. So the quotient now is the t plus delta t plus 1 times the numerator. So I can write now t times we have t plus delta t plus 1. So all over all over delta t. Now simplifying the numerator, so let us use first distributive property or using the FOIL method. So we have now g prime of t is equal to the limit as delta t approaches 0. So multiply this one using the FOIL method. So t times t is equal to t squared. Then outer terms, t times delta t, we have plus t delta t. Then inner terms is 1 times t is equal to t. And last terms, 1 times delta t is equal to delta t. Then the second term, we have t times, you have to use distributive property. So negative t times t is negative t squared. And negative t plus delta t, we have negative t delta t, and negative t times 1, we have negative t, all over the LCD, which is now t plus delta t plus 1 times t plus 1 all over delta t. So simplifying that one, so we have the limit as delta t approaches 0. So simplifying this one, so we can use cancellation. We have t squared and we have negative t squared, that's cancelled. We have also, we have positive t and the negative t is also cancelled. So next we have t delta t, this is also cancelled, and we have negative t delta t. So the remaining term there is just delta t. So we can write here now delta t over t plus delta t plus 1 times t plus 1 all over delta t. So dividing that one, that will be now equal to the limit of delta t over t plus delta t plus 1 times t plus 1 times, take the reciprocal of your overall denominator. So the reciprocal of that now will give us, we have 1 over delta t. That's the reciprocal. So delta t has a denominator of 1. Then if you're going to take the reciprocal, then it will give us now the reciprocal of 1 over delta t. So this is now delta t approaches 0. So we can cancel 1 of the delta t in the numerator as 1 delta t in the denominator. So the remaining answer here now is equal to the limit of 1 over t plus delta t plus 1 times t plus 1 as delta t approaches 0. Now, if we are going to replace delta t by 0, then this will be now equal to, so this will be, delta t here will be 0 because we're going to replace the value of delta t, which is 0. So the remaining terms now, we have the remaining answer here in the right hand side. We have 1 over t plus 1 times t plus 1, or we can write that one as 1 over t plus 1 to the quantity of, or we can write here now the product of t plus 1 times t plus 1 is equal to the square of t plus 1. So we have here the final answer now will give us g of prime of t, which is the notation for the derivative. So g prime of t is equal to 1 over the square of t plus 1. So I have another example. So find the derivative of the function using the definition of the derivative. So always remember the definition of the derivative. So since I'm using here r of z, so I can write now our definition of the derivative. We can write now r prime of z is equal to the limit of r of z plus delta z minus r of z all over delta z as delta z approaches 0. Now, replacing the value of z as z plus delta z, so using that one, we have the limit as delta z approaches 0. So we are going to use this one now. We have the square root of 5z. So instead of writing z, we are going to replace by z plus delta z minus 8. So we are done on the first term of the numerator minus the second term is r of j, which is actually this one. So we replace now by minus the square root of 5z minus 8 all over delta z as delta z approaches 0. Now let us simplify. So we can write here to simplify this radical form, so the first term is the square root of 5 times z plus delta z minus 8, and the second term is negative of 5, negative square root of 5z minus 8. Instead of simplifying the radicand on the first term, we are going to we are not going to simplify that one yet. Instead, we are going to multiply by its conjugate. Now, multiplying this equation by its conjugate, so recall the formula of conjugate, we have a plus b, okay? So the conjugate of a plus b will be multiplied by a minus b, all right? So therefore, I will multiply this one by, your a now is this one, so we will just change on this is your A and the second term is your B according to my example. So we have now to change the sign in the middle. So we can write now the square root of, this is the conjugate, the color orange. So we have 5 times z plus delta z minus 8, extend your square root, and this will be plus, instead of minus, we have to write plus the square root of 5z minus 8 all over. So we just copy only the whatever we have in the numerator. So we have the square root of 5 times z plus delta z minus 8 plus the square root of 5z minus 8. Now, the product of the numerator, so if I have this one, the square root of a plus b times the square root of a minus b, so the product of that will be equal to, we can cancel the radical sign, so the product will become a plus b times a minus b. So this is now the product of sum and difference of two terms, whose product will be the square of the square of the first term times the square of the second term, the first and the last term. So that is now we have a plus b times a minus b. So the product of that now will give us, now let's multiply now. After we multiply by its conjugate, so we multiply now the numerator and the numerator by numerator and denominator by denominator. So in multiplying by its conjugate, so we just have to square the first term. This is our first term. And the second, the last term is the square root of 5z minus 8. So to solve for that, so we just apply the knowledge of special products, and so we have the square of the first term. So we can cancel the square root and the power of 2. So we can write now 5 times z plus delta z minus 8 minus the square of the last term. So we have now we can cancel the square root and the power of 2. So we Do not forget the quantity of 5z minus 8. All over, you copy everything the denominator. So we have delta z times the square root of, we can also simplify this one now, the square root of 5z plus 5 delta z minus 8 plus the square root of 5z minus 8. So we have, we just multiply delta z times that the binomial. So simplifying the numerator, so we can write now, I can write here on the right hand side. So we have the limit of 5z plus 5 delta z minus 8, and using distributive property in the second term, we have negative 5z plus 8 all over, copy only the denominator of delta z times, we have the square root of 5z plus 5 delta z minus 8 plus the square root of 5z minus 8. Now simplifying that, so we can write now, we can cancel 5z, that one, as well as negative 8 and the positive 8 because they are additive inverse. All right. So after I examine carefully the numerator, I cancel the 5z minus 5z as well as negative 8 and positive 8. Now, the remaining terms in the numerator is we have 5 delta z, wherein we have also delta z in the denominator. So we have delta z times the product of this binomial. So we can cancel the delta z there, the one that I highlighted, the yellow one. So that will be canceled. So the remaining terms now will be equal to the limit of 5 over the square root of 5z plus 5 delta z minus 8 plus, let's extend our bar. So plus the square root of 5z minus 8 as delta z approaches 0. Maybe I can write 5 in the middle. So we have 5. Now, next step class is what we are going to substitute delta z by 0. So if you're going to substitute delta z by 0, so this term of 5 delta z will be equal to 0. So therefore, so the last step there is that we replace delta z is equal to 0. So replacing now delta z by 0, therefore 5 times 0 is 0. So this term will be equal to 0. So the remaining now is our answer, which is now equal to 5 over the square root of, okay, there is 5z here again. I forgot to write 5 in the first term. So we have here. So the final answer now will give us the answer of 5 over the square root of 5z minus 8 plus the square root of 5z minus 8. Since our denominators are the same or similar terms, so we can add the denominator. So our final answer now will give us 5 over 2 times the square root of 5z minus 8. So this is our final answer to that problem.